Hi everyone, this is Dr. Swaminathan SM. Now I am going to discuss about the topic pseudo nMOS logic. So first, what do you mean by pseudo? Pseudo is nothing but pseudo means it's not available. It is not happening. That is called pseudo. So first, the outline of today's topic to pseudo nMOS is first we need to compare the three gates and next the pseudo nMOS logic and the power calculation. So first pseudo nMOS, it's nothing but it has no PMOS. So in olden days we are following the nMOS process without any PMOS circuit. So instead of this, pull up transistor is always on. So what is the concept of pull up and pull down? Pull up means nothing but that is a PMOS transistor. So PMOS transistor is always on means we need to give the input 0. So instead of given the input 0, we just the input, that is gate, it is grounded. So gate is grounded means it is permanently on. And next the under the downside, that is pull down network, we just given the input voltage. So look at the diagram, the load that is given to the PMOS, that is grounded. So from PMOS to NMOS, the IDS current is flowing. IDS is nothing but the drain to source current. And next, the input voltage, that is V in, it's given to the NMOS transistor. The output is collected between the PMOS and the NMOS transistor, that is V out. So this is called the pseudo NMOS logic. And next, the comparison between the inverter for inverter, NAND gate, NOR gate. So commonly we can say the inverter means a series connection of PMOS and NMOS. NAND gate means dot NS. We just remember the keyword dot NS. That is, dot means denoted the NAND gate. N means nothing but nMOS. S means nothing but series. So nMOS is series means that is NAND gate. If nMOS is parallel means that is NOR gate. So look at the common generic diagram in the right hand side. So PMOS is grounded and the input which is given to the pull down network, that is F. So it is used to design for the unit current on output to compare with the unit inverter. So PMOS always fights with the nMOS. Next, the comparison between the inverter NAND and NOR gate means the gain of the upper transistor 4 by 3, the down transistor 4 by 9, and average will be 8 by 9. And same thing for pull up network power and pull down network power and average power, everything is given for inverter, NAND gate, and NOR gate. So this is the comparison. And next, we need to define the K input, that is estimate the delay driven the fan out. So fan in nothing but number of input which is given. Fan out is nothing but number of output which is taken from the particular circuit. So G is nothing but 1 into 8 by 9, that is 8 by 9. F is equal to fan in GBH. And P is nothing but power calculation. N is nothing but number of stages, that is 2 stages it is available. One is inverter, another one is NAND gate. So that is 2 stages. So N is equal to 2. And next the delay is equal to, that is the power NF 1 by N plus P. So this is called the pseudo nMOS. And next the power calculation. So P is nothing but V into I. So voltage into current, that is P. So the PMOS, that is pseudo nMOS, it draws the power when Y is equal to 0. So Y is nothing but output. If enable bar which is given, that is En is equal to 1, so En bar is equal to 0. So PMOS is permanently on. So A, B, C is the 2 and plus 3 inputs which is given to the nMOS transistor. So that is, it is called 3 input nMOS transistor. So the problems which is occurred, that is a ratio issue and power sharing, charge leakage problems. These are all the things that happened in the pseudo nMOS transistor. That's why we will go for the dynamic logic. Thank you. So next to the dynamic logic, it is overcame. That is the static and pseudo nMOS and the dynamic, which is used for the comparison. So the dynamic logic, which is uses the clocked CMOS pull up, there is two mode which is useful for pre-charging and evaluation. So pre-charging is nothing but like charging, evaluation is nothing but discharging phases. So in the static it is normal, and the pseudo nMOS, the second gate, that is given to the grounded. So PMOS is permanently on, and dynamic is nothing but we just given the clock input, that is called pi. So the foot transistor, which is useful for the dynamic logic, whenever it is needed we can use the foot transistor. So that's all. This is called the pseudo nMOS logic, and following with the pseudo nMOS logic we are using the dynamic logic. Thank you.